Have you ever felt like the world is just completely random? Well, what if I told you there's a hidden force, a secret language that finds perfect, predictable patterns in the most chaotic parts of our lives? Today, we're going to learn that language.
I mean, think about it. Our daily lives are just a whirlwind of unpredictable moments. Will the next shot actually hit the bullseye? Is this coin going to land on heads or tails? Will the next gadget that comes off the assembly line work perfectly? Each one on its own feels like a total mystery, right? Just a single moment lost in a sea of noise. But here's where it gets amazing. Something incredible happens when we zoom out. When we stop staring at just one coin flip or one single gunshot, and instead we look at thousands of them, or millions. All that chaos, it starts to settle down. It's like a blurry photo slowly snapping into sharp focus. And suddenly, you can't deny it. Patterns emerge. So what is this hidden rhythm? How in the world can there be consistency in things that are by their very nature completely random? And, more importantly, how can we measure it? That's the mystery we're about to unravel. The key that unlocks this whole thing. The name for this mind-blowing phenomenon is a word you definitely already know. But you're about to see it in a whole new light. It's called probability. So what is probability, really? Let's forget the dense textbook definitions for a second. At its core, it's actually a super simple and honestly pretty intuitive idea. See, at its heart, probability isn't about some magic power to predict a single coin toss. No way. It's about knowing that if you flip that same coin 1,000 times, you can be pretty darn sure that the number of heads is going to be really, really close to 500. It's the story that gets told over the long run, not in just one single moment.
And we can boil this whole powerful idea down to one simple fraction. The probability of something happening is just the number of times it did happen divided by the total number of times you tried. That's it. Successes over tries. It's really that straightforward.
Okay, theory is one thing, but let's make this real. Let's see how this simple formula actually works with our first example, the marksman. All right, here's our data. Our marksman takes 100 shots. That's our B, the total number of trials. Out of those, they hit the target 92 times. And that's our A, the number of successful outcomes. Simple as that. We have the two pieces of our puzzle. So, what do? We take our 92 hits, we divide by the 100 shots, and we get 0.92. This one little number tells the whole story of our marksman skill. We can now say they have a 92% probability of hitting the target. And this, right here, this is the most important part to get. That number doesn't mean the next 100 shots will have exactly 92 hits. Think of it like a batting average in baseball. A hitter with a .300 average isn't guaranteed to get 3 hits every 10 at-bats. It just means that over a whole season, their performance is going to average out to be very close to that number. It's all about the long game. Okay, let's try this again. We're going to apply the exact same logic to a totally different scenario. We're leaving the shooting range and heading to a factory floor, where this time, we're going to measure the probability of something going wrong. So here's the deal. A factory produces 1,000 items. That's our total number of trials. But when they do quality control, they find that 16 of them are defective. That specific outcome, a defect, is what we're measuring. So let's find the probability. We take our 16 defective items, divide by the 1,000 total items produced, and that gives us a probability of 0.016, or, put another way, just 1.6%. And this brings up a really interesting little quirk in the way we talk about probability. Now, to the factory, a defect is obviously a failure, right? But in the world of probability, we'd actually call it a success. And you might be asking why? Well, it's because success simply means that the event we were looking for actually happened. It doesn't care if the event is good or bad, just that it occurred. Kind of neat, right? All right, controlled examples are great for learning. But the real magic of probability, the thing that makes it so powerful, is when we apply it to messy, unpredictable, real-world data. This is where it all comes together. So, take a look at these birth numbers over 3 months. In January, you've got 1 ratio of boys to girls. In February, it changes. Then in March, it changes again. If you just look at it month by month, it looks completely random, totally unpredictable. For January, the probability of a boy being born works out to about 51.8%. But then in February, it drops down to 51.1%. And in March, it jumps all the way back up to 52%. See what I mean? The numbers are all over the place, up, down, then up again. It feels totally chaotic, which just confirms that initial feeling of randomness. But watch this. Watch what happens when we stop looking at the months one by one and we combine all the data together. Suddenly, all those wild swings, they smooth out. The noise just cancels itself out, and the true underlying signal emerges, a stable, predictable probability of around 51.6%. That's it. That's finding order in the chaos.
So what's the big takeaway from all this? Well, it's that probability isn't some crystal ball for predicting the future. It's a tool, a really powerful tool for understanding the predictable patterns hidden inside the chaotic world around us, but only when we're willing to look at the big picture.
So let's just wrap this all up. We've learned that probability isn't about any single event. It's about what happens in the long run. We know it's just a simple fraction, outcomes divided by trials, and it gives us this incredibly powerful average we can count on, as long as the conditions stay the same. It can't tell you what will happen next, but it can perfectly describe how the whole system behaves over time.
And that leaves us with this final, really powerful question. We've just used a simple fraction to find predictable order in gunshots, in factory defects, and even in something as amazing as childbirth. So, if a pattern this reliable is just hiding in plain sight, what other incredible patterns are we walking right past, totally unaware, every single day? If this helped you see the world just a little bit differently, do us a huge favor and hit that like button, and make sure you follow so you don't miss what we break down next. And I really want to hear from you, so share your thoughts in the comments. Where have you seen probability at play in your own life? Maybe it's in your favorite sports stats, a board game you love, or even just trying to guess when the next bus will show up. I'd love to read your examples. Thanks so much for watching.